Hi everyone, welcome in our MobiliseYourCity emissions calculator tutorial. I am Mary Carlson. I work in IFOI, Institut für Energie und Umwelt, so Institute for Energy and Environment in Heidelberg in Germany. I am specialized in the transportation sector and I will guide you through the MobiliseYourCity emissions calculator tool thanks to this tutorial. We have 4 videos to explain you this tool, to calculate the GHG emissions of road and rail transport in your city or your country. We have first this introduction to the MobiliseYourCity methodology and the emissions calculator. We have the second video, which is a tutorial on inventory and BAU scenario. The third video is on tutorial on climate scenario, both passengers and freight. And the fourth one is a short one focused on some expert options. So the first question would be, is it really important to calculate the emissions of transport? Actually, it is. It is for several reasons. One of them is that the share of transport emissions in different cities is quite high. It just depends, of course, on the cities. It depends also on the country, if you're a country. If you want to have an estimation in several cities in Germany, as you can see on the screen on the top left, it's between 12 and 23% of the total GHG emissions of the city. You have an example on the right side of Sfax in Tunisia. That's quite high in comparison. It's more than 50% of the emissions that are coming from transportation. For a country, for Germany, for example, it's around 25% also. You will have to discover, or maybe you already know approximately how much it is. What is also important to say, it's a quite high amount, but it's also growing. You can see it here in Chile, in Antofagasta. The emissions of transportation in the city, they have been growing in the last decade. And that's the case worldwide. It's not only a phenomenon in Chile, it's of course global phenomenon that the GHG emissions of transport are just growing every year. So why this tool? It's important to give you some understanding at the beginning, what is it for and how it works. So what's the goal? It's to calculate road and rail transport GHG emission of a city or a country. You don't have navigation and aviation into this tool. Our focus is on developing countries. There are some, let's say, features that make it easier for developing countries than with other tools, which are also well known, such as Copert or Tremot, that are much more complicated and too complicated for those cases. So it's really targeted for this usage. You can, within the tool, calculate different things. You don't have to calculate everything, but you can have the inventory of the transport emissions of your city or country. That means the current situation, how much you are emitting today. You can stop afterwards if you don't want to make any projection. If you want so, you have the possibility to do a business as usual scenario up to 2050. And finally, which is also quite interesting, is when you are planning to improve your system, is to know how much you're reducing through the measures that you're planning. And that's the third part of the tool, where you can calculate the GHG emission reduction of one climate scenario for road and rail transportation, of course, which is in the context of a SUMP or a NUMP quite useful.
and of course for passenger and freight. Moreover, our tool is available in English, French, and Spanish. You just have to choose at the beginning which language you want to have. And we have tried as far as possible to balance between the data need and the complexity of the tool. It's a complicated balance to find. Don't hesitate to give us some feedback on the tool, generally speaking. Even if you see a mistake, for example, it can be in the language, or you find something that is not in there and yet you need. Or on the contrary, there are too many data and you can't cope with that. Please contact MobiliseYourCity and give them feedback. It's quite useful for us. One point is that the tool is quite new. It's been developed or finalized in 2020. So we are quite up to date. I would say we recommend, if possible, that you use a transport planning tool together with this GHG emissions tool, because of course it will be more accurate if you can have exactly the transportation data of your city, which are not approximations, but really coming from transportation planning tools and experts. Finally, which may be of importance for some of you, the calculations are compatible with the IPCC guidelines for the inventory, so you can use the results of the tool to feed your inventory. We don't calculate all the emissions, for example, of pipelines. We don't have that in the tool, but you have maybe 95% of the emissions that are covered for road and rail, and the rest you will have, of course, to complete if you want to send your inventory to IPCC. If you have any question, as I said, contact the MobiliseYourCity Secretariat. You have here the email address. Feel free to do so.
Before starting, you may have some questions about this tool. For example, how long does it take to learn using the tool? I would say at least 2 days. You should plan 1 day to read the methodology, which is called the MobiliseYourCity guidelines, which includes the data list you need for the tool, and there is also a user guide. You should also plan at least 1 day to watch all the videos and try to exercise on the tool. For example, you can enter your available data, and if you don't have all data, you can also use hypothesis to try to calculate some dummies scenario and inventory. That really helps to practice. So really plan these 2 days. The question, of course, afterwards is, where is this documentation if we want to read it? It's on the MobiliseYourCity website. You have the link on the screen. Here you can find the guidelines, the user guide, and the videos. And of course, a good question would be, how long does it take to calculate the transport GHG emission of my city, of my country? Well, you could expect the answer. It depends. It depends on the data availability, if you already have a lot of data or not, if you need to have time to build hypotheses. And of course it depends on if you have a transport planning tool. With a transport planning tool, it's going to be very quick in comparison to an option without it. To give you an order of idea, I would say for the inventory you should plan around 20 minutes to fill in everything, and afterwards read the graphics, check if everything seems correct, if the data are already available, of course. For the BAU, it's around 10 minutes. It's quite quick because it's just a projection of the inventory. So if you know the growth rates for the different data input, it's going to be quick. For the climate scenario, passenger freight, if you have the first approach, as I've said, with the transport planning tool, it's also not such a big thing. You need around 10 minutes to fill in everything. If you choose the second approach, though, it may be a bit longer. I would plan at least 30 minutes to check the inputs to see if everything also makes sense. But assuming, once again, that the data are available. If you need to think about what you want to do during filling the tool in, then you need a bit more time, like maybe some hours. Finally, the quality check, I would really emphasize that you should plan at least 2 hours to check everything. It's very quick to do a mistake, and you need to look for them. You can help you with the top-down and bottom-up tab, where you can compare some data with the data you already have of your energy balance. You can use the KPIs to see if they seem reliable. And do not hesitate to bring colleagues or to have any workshop to speak about your results and see if anyone sees anything, has comments or something like that. It's a very important step. Finally, what takes the most time is not filling in the tool, actually. It's gathering all the data you need in the right format with the right unit. It's something you really need to pay attention to, is unit. Well, I hope it gives you an insight of how long you should plan and where you can find the resources.
So what is the content of the tool? Quite quickly, because afterwards we'll deep dive into the tool, into the Excel file itself. You have the inventory, as I've said, for road and rail. You have to provide kilometers, depending on the fuel, the vehicle types. And of course, you will have, if you want to do a business as usual scenario, you will have to give growth rates and give some data on the transportation system you will have tomorrow in your city, at least what you think will happen. And afterwards, at the end, you have to give some input on the climate scenario, what will be the change in comparison to the BAU. So which share of the transportation demand will be avoided thanks to the bundle of measures you're planning to have, which share is shifted, and which share is improving in terms of fuel efficiency. The outputs you will have after you give all these data are first the transport performances, the person or ton kilometer for the entire territory, city or country. You will have also the total mileage. You will have the modal split, of course, which share of the emissions are due to cars, are due to trucks, and so on. And of course, the total GHG emissions of your territory. At the end, you also have some graphics showing the savings you can plan with the current climate scenario in comparison to the business as usual scenario, and that for some reference years. So you have the base year, you will have to define the base year. You have 2020, 25, 30, 40, and 50. As I said at the beginning, you have different literature, different guidelines to help you understand the methodology, but also the tool itself. On this slide, you can see very important document to read. It's the monitoring and reporting approach for GHG emissions. That's the base methodology that we are following also in the tool. So please feel free to download it and read it. One point that's very important to know, which is written into this methodology, is the territorial approach. We recommend to use this approach, which is based on the functional city. That means the city boundary you are defining at the beginning. You can decide if it's just a city center, if it's the metropole area, if it's the region. But in all cases, once it's defined, you stay with these boundaries and you try to calculate or to extrapolate, depending on what data you have, what is the transport demand and how many kilometers are done by the different vehicles into these boundaries. That means the inhabitants, but also the visitors, the vehicles that are going through your territory. So it's a important fact, an important point to be able to say these are really the emissions of our territory. Another point of the methodology, which emissions are we calculating? We are calculating the GHG emissions, so greenhouse gas, which are the three gases here, so CO2, methane, and nitrous oxide. That's set in the tool, but you can decide to have the tank-to-wheel emissions, so that means only the direct emissions created by consuming the fuel into the vehicles, or you can decide to have the well-to-wheel emissions. That means also the emissions from producing the energy. That means the electricity, but also for diesel or gasoline, that you have then the entire emissions of the transportation system. So you have to define which one you want to see. Upstream emissions are not included into the IPCC. They are in the energy sector. So for IPCC standards, you will have to use just tank-to-wheel. But if you want, for example, to compare two technologies, such as the electromobility compared to the classical mobility, let's say with diesel or gasoline, then you would need to take both, to take the well-to-wheel emissions to make a fair comparison. How do we calculate the GHG emissions? We follow quite classical approach, which is called the ASIF approach. We take the total activity in kilometer. We multiply it with the modal split, with which part of this activity is imputed to cars, to motorcycle, to buses, and so on and so on. And we multiply it with the energy intensity, the fuel consumption, liter per kilometer. And we get the total fuel consumption within your territory. We multiply it with emission factors in CO2 equivalent per liter or per megajoule, which are given by the IPCC. That's the one that are embedded in the tool. And through that, you get the total GHG emissions. The data need. So, as you can see on the screen, you need quite a lot of data. You have the data need list, where everything is listed and explained. There are also a lot of information into the methodology, where you can find some data, how you can collect them. There are socioeconomic data, there are transport data, data on the fleet itself. And as you will see in the next slide, there are also some data on energy consumption that you have to gather. So don't be afraid. It seems a lot because you're calculating a lot of things actually. but it's really manageable. You just have to take one by one. And of course, if you're if you're a city or a country, the sources will not be the same. For the city, of course, you can use some defaults coming from the national authorities. For example, the share of diesel and gasoline cars within the fleet. Maybe you don't have the data at your city level, but most of the time, the national level will have this kind of data. So once you have the inventory and the business as usual scenario, you have to calculate the climate scenario. You will have to bundle the measures according to these three possibilities. Avoid measures, that means the measures that are avoiding trips. For example, home office. Then you will have to bundle the measures that are concerning shift, which in most of the cases increase the sustainable modes, such as biking or public transportation. And finally, you have to bundle the measures that are looking at improving the fuel efficiency. For example, if you use biofuels or if you use electromobility, then you bundle all these measures together and you calculate what's the impact of all these measures together for each given year, so 2020, 25, and so on. And you give just one result for each of these points for the different vehicle modes. That means if two of your measures are concerning cars and that enables avoiding trips, then you have to add these two effects of the two measures together and give just one data into the tool. So be aware that you have also to take into account the interactions. Of course, if it's 5% reduction and here 5% reduction of the kilometers of cars in your city, it may not be 10 at the end of the day. If you implement the two at the same times, maybe there will be an interaction and the sum of the two will be 8% of the entire mileage savings. You really have to think about that and try to be as near as possible to what would be in the reality and do the best in assessing the impacts.
It's important to emphasize that such an exercise is always better and more precise if you have a transport planning tool, a model. If you don't, you will have to rely on calculations and on expert knowledge, though we really recommend to use such a tool and rely on transport engineers to model your future transport demand in your city or your country.
And finally, you will get your results, so what you're expecting from the beginning, the inventory, so with the different transport modes. You will have a scenario for passenger and the same for freight. So you have different format of graphics showing in any case how much you're saving in the different reference years, comparing BAU and climate scenario. And you have also the entire picture, so freight and passenger together, to see how much you're saving on your territory.
And at the end, a very important part that must not be forgotten is the monitoring of your implementation and the impact of your measures. That's why we have created a part which is called KPIs in the tool. and these key performance indicators will give you where you stand. You have general KPIs that are linked to population and GDP. You have passenger transport KPIs. They are giving you the type of mobility, the intensity, carbon intensity of your passenger transportation system. You have freight transport GDP, KPI, sorry, and the carbon intensity, for example, of your freight. You have here some example of values that you could have in your tool. For example, a ton CO2 per inhabitant value for 2016, it's base year 0.8 around, and for your BAU, it's going to be quite worse with 1.3 in 2030, and for your climate scenario, because of your measures, you're getting almost at the level of 2016, but still a bit more, 0.9 ton CO2 equivalent per inhabitant. So you can see the path you have to follow, and you can track your improvements in the time frame. You also, of course, have KPI for the passenger transportation, for example, the modal split comparison of individual transport, public transportation in percentage. You have for freight transportation also a bundle of KPIs, for example, which is the share of road and the share of rail transportation in your system for 2016, 2030. You see that we are planning to have quite an improvement in this case because of measures trying to shift road to rail. That's the end of it. That's the end of the introduction of the frame and the methodology of our tool. I hope you have a good insight now, and I invite you to go to the Excel file, open it, and take the next video on the Excel file itself. I will guide you through all the inputs so that you will get at the end your GHG emissions for the inventory, the business as usual scenario, and the climate scenario. Don't hesitate to contact me if you want. And of course, you can contact the MYC Secretariat at any time.